I specifically wanted to do this one on a video because I can show you something that I can't show you in real life. Okay, so what I wanted to do is show you that I'm going to look at this string of digits here. And let's say the first string you're going to handwrite. And you should notice 17 minus 1 is 16, right? And all 16 remainders are represented because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 16 digits. Remember, the digit is not the same as the remainder, but for every remainder that shows up in the division problem, so you go 1 divided by 17, remember we did this in class, and you start with 0, and the next thing you try is 5. 7 times 5 is 35, 8, and so on and so forth. So in this case, you had a remainder 8, and the remainder 8. I'm sorry, the remainder. What do we have after all? We have 15. 15. Okay, so we have a 15, but that's not the same as the digit string. So the remainder string is separate from the digit string, but they are correlated in the sense that we have a repeating remainder stream and we have a repeating digit stream. So the fact that we have a pile of 16 repeating digits means we went through all 16 possible remainders. And you may say, but what about 17? What about remainder 0? The point is, if you get remainder 0, it will break the cycle. And we have certain conditions when that happens. But assuming that this guy is, what's it, the denominator, if it has this pattern, okay, then the thing will terminate. But we don't have this pattern. It's not, this denominator is not comprised entirely of 2's and 5's, so we have no hope of terminating this unless the numerator were a perfect multiple of 17, which it's not. Okay, so those are all the cases. So we've got the most basic case possible, which is that we have all the remainders in one cycle. Another possibility would be we could have had 8 remainders in one cycle and 8 remainders in another cycle, or we could have had 4 sets of 4. But all the remainders have to show up somewhere, and we got lucky because we only have one stream of remainders. Okay, so the question is, what is the next thing we could possibly encounter? Well, you could cheat. This is legal. 2 divided by 17, you could get the first couple digits. It's 0.117, and that's totally fine. I don't mind if you start out that way. But then you say, aha, this is where we start the cycle. All right? And so it's 0.176470588235294. And then it starts over again. And you see, I have to pick something that's a long enough string that you can't just do it on your calculator. Your calculator doesn't have that many digits. So you have to rely on the fact that you know where to end it and it loops around. Okay, then what is the next cycle going to look like? Do you have to use your calculator again? I mean, you're welcome to, but it's not necessary because it's just sitting right in front of your face. If 11... okay, it's sitting right in front of you, and 17 is the next place you're going to start. So you're going to start with 17. I got to put this guy back before I lose it. But I'm going to start with 17 this time. And then that 1 from the other end, I'm going to just pop it over here. And put another bar on top. Okay? So what's the next thing? After 11 and 17, you should see a pattern. 0, 5, 11, 17. I'm just looking at these two digits here. I'm looking at 11, 17, and there's a 5 up there which I can't color. What's the spacing? It's kind of like every 5 or 6, plus 5 or 6. It's always going to be plus 5 or 6. So we would expect the next one, what's 17 plus 5? 22 or 23 is what we're expecting. So we look and say, aha, there is a 23. And so I'm going to just copy and paste this. All right, but Instead, I'm going to split it at 23. So 23 is going to go in the beginning. It's exactly the same string of digits, and I'm just doing this to it. And again, if you're at all hesitant, you can just pull out your calculator and say, are we doing this right? 4 divided by 17, and it's 0.235. Okay, so we've got the thing started correctly at least. All right, now what's the next one going to be? Okay, again, paste it down. What's 23 plus 5? It's like 28, but it's actually 29. So 29 is where we're going to split the next one. All right. Not too hard. And what's 29 plus 5? It's like you're close to 35. And 35 is the next one. Okay, we're just going to split it off at 35. And 35 is what we're going to do to start this guy off. Move those over, make room for the 35. Okay, and so on and so forth. And so we have this progression that we're now looking at: 11, 17, 23, 29, 35, and it's always going to be off by some number or some number one more, like always off by 5 or 6, or always off by 7 or 8. It's going to be, you know, 2 consecutive numbers, and those are the only 2 things it can possibly be. Then what about if we have this question? How do we know what 16 over 17 is? Well, it has to start with the highest possible combination. So that's going to be 94. You see, 94 is the highest possible way we could start this string. And so we just go ahead and do that. And then what's the second highest way we could start this? Well, if 94 was the highest, then 88 is going to be the second highest. You just look at the string of digits and see what your possibilities are. Okay, and then you're good to go. And again, if you're at all nervous that you started on the wrong digits, which you should try, you should be careful. 15 over 17. Yep, there it is. 16 over 17. Yep, there it is. But in order to get the answer right for the question, you have to put down the entire string of digits for each question. That's why there's so many skips. If I just wanted the first 2 digits, I'd make you fill in the whole chart, but that's pointless. What I'm trying to get you to understand is the structure of our number system. I want you to understand that this string of 16 digits will repeat forever and ever. And I want you to understand that you don't have to go to your calculator and type it in. That if you already have that string of 16 digits, you can just make it cycle around until it's in the right place, and you can sort those. And this is the technique I wanted you to learn, and this is the learning I wanted you to experience from this exercise. So I hope that was helpful, and I hope you liked the video, because I couldn't quite do that on the chalkboard, changing the colors and swapping the numbers around like that. So hopefully that helped a few of you understand.